Good morning. I am Dr. Jinish. I am from Department of Chemistry, Ramaya University of Applied Sciences. Welcome to the course Engineering Chemistry. I will be taking the lectures for you for this course Engineering Chemistry. Today is introduction session. In this session, I will discuss mainly 5 points. We will discuss about what are the major topics or units in this course. What are the intended learning outcomes for this course? What are the course contents? What are the things that we are going to study in this course? What are the resources required to study these courses? That means which are the books, what kind of notes you will be getting. Those informations also I will be providing in this lecture. Last, I will give you introduction, a very brief introduction about the first unit, that is Introduction to Electrochemistry. Welcome to the course. The course is divided into 8 different units. They are Introduction to Electrochemistry, Storage Devices, which contains both batteries and fuel cells, Corrosion Science, Metal Finishing, Chemical Kinetics, Fuels and Flue Gases, Polymers, Introduction to Nanoscience and Nanotechnology. What are the intended learning outcomes from this course? At the end of the course, students are expected to solve or answer the following questions. First one, explain the basic concepts of electrochemistry, conversion of chemical energy into electrical energy, theory of corrosion, and principles of metal finishing. You should be able to differentiate renewable and non-renewable fuels, primary and secondary electrodes, primary and secondary batteries, batteries and fuel cells, electroplating, electroless plating, thermosetting, thermoplastic polymers, dry corrosion, and wet corrosion. You should be able to discuss the reaction chemistry and stoichiometric combustion of fuels, remedial measures to control oxides of nitrogen, sulfur, and carbon, the polymerization methods, mechanism, preparation, properties, and applications of some polymers, concepts of nanoscience and nanotechnology. You should be able to identify the types of corrosion and methods to prevent corrosion, suitable polymers and nanocomposite materials for engineering applications. You have to derive the kinetic rate equations for various chemical systems and equations for electromotive force. Last, you should analyze the suitability of polymers and composites for various applications and problems related to chemical kinetics, electrochemistry, corrosion, and metal finishing. Our first unit is Introduction to Electrochemistry. In this course, we will study about different types of electrochemical cells, the concept of electrode potential generation and electromotive force in a galvanic cell. We will study about different types of reference electrodes. We will solve numerical problems related to electrode potential or cell EMF of galvanic cells. We will study about the construction and working principle of ion selective electrodes. Second unit is storage devices and conversion devices. In storage devices, we will study about batteries. We will study differences between primary and secondary batteries, construction, working principles, properties, advantages, disadvantages of both primary and secondary batteries. We will also study about the conversion devices such as fuel cell, how to construct a fuel cell, what is the working principle behind the fuel cell, what are the advantages and disadvantages of fuel cells. Also, we will study the differences between a battery and a fuel cell. Unit 3 is about corrosion science. We will study about different types of corrosion. We will study the theory behind the corrosion. What are the factors affecting the corrosion? How to prevent the corrosion? How to slow down the corrosion of metals? All these points we will study in the third unit, that is corrosion science. In the fourth unit, metal finishing, we will study about the importance of metal coating, how to do electrode deposition of one metal over another metal, how to do electroless plating of metal on another metal, and what are the differences between electroplating and electroless plating. In the fifth unit, chemical kinetics, we will study about different orders of reactions. What are the factors affecting the rate of reaction? Why some reactions occurs at faster rate, why occurs at a slower rate, etc. In unit 6, we will discuss about different types of fuels, classification of fuels, sources of fuels, how we can characterize a fuel, what are the characteristics of a good fuel, how to do petroleum refining, what is the importance of petroleum cracking, what is knocking and its effect in petrol-based engines, what are the anti-knocking agents. We will study about how to synthesize bio-based fuels. Then we will study about what are the reasons behind flue gas generation in the atmosphere and how to control the flue gases in the atmosphere. In polymers, we will study about the classification of polymers, types of polymerization, mechanisms of polymerization, the properties of polymers, what are the differences between petroleum-based polymers and biodegradable polymers, what are the important polymers and their applications, etc. In the last topic, we will study about what is nanoscience, why materials behave in a different manner when they are converted into nanoform, how to synthesize nanomaterials in the laboratory, what are the applications of nanomaterials, what are the major nanomaterials being used in industries, in computers, in sensors, in automobiles, in aerospace, in medical applications. Those things we will study about in the last unit, which is nanoscience and nanotechnology. These are the resources that you require to study this course. Class notes in the form of PPT will be provided to you at the start of this semester. I will be giving my own comprehensive lecture notes. I will be providing the notes before each unit. So today I will give you the first unit's lecture note. Engineering Chemistry by O.G. Pallana, very simple and very good book for undergraduate students. Advanced Physical Chemistry, where you can learn more information about chemical kinetics using Gurudeep Raj textbook. Nityananda Shetty and Gadak, they have written one book, Engineering Chemistry, that is also a very basic book which is useful for undergraduate students. Last, the resources, that is a textbook of nanoscience and nanotechnology written by Dr. Pradeep. That is also a very good book to understand the basics of nanoscience and nanotechnology. So these are the resources that you require for studying this course. We will start today's lecture by mentioning the milestones in the field of electricity and electrochemistry. This will help us to gather knowledge about how the field of electricity and electrochemistry was introduced and explored. Benjamin Franklin in mid-18th century has carried out the famous kite experiment. Flying a kite in a storm was perhaps Benjamin Franklin's most famous experiment that led to the understanding of connection between electricity and lightning. This connection, which was already known but not fully understood that time. The kite experiment is a scientific experiment in which a kite with a pointed conducting wire attached to its apex is flown near thunderclouds to collect electricity from the air and conduct it down the wet kite string to the ground. It was proposed by Benjamin Franklin with the assistance of his son William Franklin. The experiment's purpose was to uncover the unknown facts about the nature of the lightning and electricity, and with further experiments on the ground to demonstrate that the lightning and electricity were the results of the same phenomena. So what is the takeaway point from this experiment? Lightning and electricity were the result of the same phenomenon. This experiment led to the understanding of connection between electricity and lightning. So Benjamin Franklin identified that the lightning and electricity were the results of the same phenomenon. All of us are using different types of batteries for our different electronic equipments. Batteries provided the main source of electricity before the development of the present electric generators and electrical grids around the end of the 19th century. Presently, the most contributing electrical energy resources or source is electric generators, which is kept either in hydroelectric power station or thermal power station or nuclear power station. But before 19th century or before the end of the 19th century, batteries provided the main source of electricity. Improvement in battery technology facilitated major electrical advances from early scientific studies to the rise of telegraph, telephones, eventually leading to portable computers, mobile phone, electric cars, and many other electrical devices. Now, in the present scenario, we use lithium-ion batteries mainly for powering either your vehicle or your mobile phone, laptops. Louis Galvani, an Italian physicist, discovered something he named animal electricity when two different metals were connected in series with a frog's leg and to one another. He found that when two different metals are connected to a frog's leg, the legs of the frog suddenly moved. He named this observation as animal electricity. But Galvani couldn't explain what is the reason behind that animal electricity. Alessandro Volta, he realized that frog's leg served as both a conductor of electricity, presently we call it as electrolyte, and as a detector of electricity, we can call a frog galvanoscope. Galvanoscope is an instrument which can measure the presence of electricity. So he identified that frog's leg is acting as a detector of electricity. So frog's leg acts as a conductor or an electrolyte as well as a detector. That's the reason when two different metals were kept on frog's leg, the frog's leg was kicked. He identified that. I think you have studied about galvanoscope as a detector of electricity, right, in your PUC and in your high school. Volta also understood that the frog's leg were irrelevant to electric current, which was caused by the two different metals. So he replaced frog's leg with brine-soaked paper. So he needed one electrolyte. So he didn't use frog's leg. Instead of that, he used brine-soaked paper as its electrolyte. Brine is a concentrated solution of salt. All of you know that. He detected the flow of electricity. So instead of keeping frog's leg, if you are keeping only two metals in a brine solution, then also the electricity will produce. He understood that concept. He verified his hypothesis through different experiments and published his results in 1791. So he understood with the two different types of metals, and if you have one conductor of electricity, presently known as electrolyte, then you can generate electricity. He got that idea in 1791. After that, in 1800, Volta invented his first true battery, which came to be known as voltaic pile. You can see the photo of voltaic pile in this slide. This voltaic pile consisted of pairs of copper and zinc discs piled on top of each other, separated by a layer of cloth or cardboard soaked in brine. So in voltaic pile, you can see piles of copper and zinc plate. So piles of two different metals dipped in brine solution, a paper or a cloth which is dipped in brine solution, which acted as an electrolyte. And he found that electricity is produced. The voltaic pile produced a continuous electricity and stable current and lost little charge over time when not in use. We studied that Alessandro Volta, he invented battery. But even after the invention of first battery, there was no information about the relationship between chemical reaction and electricity. Alessandro Volta was not having any kind of idea how the electricity is produced. He was unaware of the electricity is produced by a chemical reaction. Sir Humphrey Davy in 1806, just after 5 years of the invention of the first battery, proved the relationship between chemical reaction and electricity. Humphrey Davy was a pioneer in the field of electrochemistry who used electrolysis to isolate many elements from the compounds in which they occur naturally. For example, presently, I'm not talking about what Humphrey Davy did. Now we know that aluminium we used to get it from its ore, bauxite, using electrolysis. So if you can do electrolysis of bauxite ore, we will get aluminium. That is known as an electrolysis based isolation of one element from its compound. Electrolysis is the process by which an electrolyte is altered or decomposed by applying an electric current. So Humphrey Davy, he identified the relationship between chemical reaction and electricity. Also, he used electrolysis to separate elements from its compounds. So we can say Humphrey Davy discovered the field of electrochemistry. In 1820, Hans Christian Ørsted performed an important experiment which showed that there was a connection between electricity and magnetism. We will study what he had done. He passed electricity through a wire and kept one compass near to the wire, like in this figure. When a current was passed through a wire, it made the compass needle to deflect. You have studied this experiment in your school that when you studied about electromagnetism. So this introduction or the concept of electromagnetism came in 1820, which is from an experiment done by Hans Christian Ørsted. At the same time, in 1820s, Ampere identifies the current as the source of all magnetism, even permanent magnets. Although he was not the first person to observe a connection between electricity and magnetism, we know that already Ørsted had done some experiments which relates magnetism and electricity. Although he was not the first person to observe a connection between electricity and magnetism, Ampere was the first scientist to attempt to theoretically explain and mathematically describe the phenomena. Even though Oersted did an experiment, he couldn't explain the theory behind this electricity and magnetism. Ampere, he attempted to theoretically explain with the help of mathematics to describe this phenomena. His contribution laid the groundwork upon which the science of electrodynamics, a term coined by Ampere, but now more commonly referred to as electromagnetism. Now we call it as electromagnetism. At that time, Ampere called it as electrodynamics. In 1831, famous scientist Michael Faraday experimentally discovered that a time-varying magnetic flux through a conducting loop also generated voltage and thus electric field. So Michael Faraday experimentally proved that if you vary the magnetic flux inside a conducting loop of a conductor, then you will get a voltage or electric field. You already studied this in your school. And he found that electric field and magnetic fields, they are coupled. You studied those things as electromagnetic induction in your school. His main discoveries include the principle underlying electromagnetic induction, diamagnetism, and electrolysis. He invented the first electric motor in 1821, which is given in the second picture. First dynamo in 1831, shown in the third picture, and later he found out the concept or the reasons behind electrolysis. After Michael Faraday's experiments, Serbian-American engineer and physicist Nikola Tesla made dozens of breakthroughs in the production, transmission, and application of electric field. He invented the first alternating current motor and developed AC generation and transmission technology. You can see how the first alternating current motor looks. By studying all these milestones, now we know that there is a clear interaction or interrelationship between electricity and chemical reaction, and even electricity and magnetism. So now we know there is a relationship between chemical reaction and electricity, magnetism and electricity. Summary of today's class. We studied about 8 units in engineering chemistry. The intended learning outcomes from this course. What are the course contents that you have to study? What are the resources required for studying this course? Milestones in electrochemistry. Welcome to the second lecture of the course Engineering Chemistry. Today we will study about the terminologies associated with the electrochemistry. Learning outcomes from this lecture. At the end of the lecture, students will be able to define electrochemistry and electrochemical reactions. You will be able to define redox reaction. You will be able to identify oxidation, redox reaction, reduction. You will be able to discuss the terms such as anode, cathode, and electrolyte. Now we know that electrochemistry is a 200-year-old science, and we will define electrochemistry like it is a branch of chemistry that studies the relationship between electricity and chemical reaction. Electricity and chemical reaction relationship, those kind of reactions are known as electrochemical reaction. So definition of electrochemical reaction is if a chemical reaction is caused by electric current or electric current is produced due to a chemical reaction, then the reactions are known as electrochemical reaction. So two types of electrochemical reaction. If a chemical reaction is caused by electric current or electric current is produced due to a chemical reaction, we can call those reactions as electrochemical reaction. For example, electricity is produced in a battery due to the chemical reaction. So here chemical reaction happened and due to that electricity produced. So it is an electrochemical reaction. Similarly, if you are doing electrolysis of water to split water into hydrogen and oxygen, here you supplied electric current and chemical reaction occurred as the result of the supply of electric current. This reaction is also an electrochemical reaction. So in the first example, electricity is produced by chemical reaction, and in the second reaction, a chemical reaction occurred due to the supply of electricity. Both are electrochemical reactions. In your PUC, you studied about voltaic cell and electrolytic cell. The reactions happens inside the voltaic cell and electrolytic cell. Both are electrochemical reactions. In voltaic cells such as galvanic cell, electricity is produced due to the chemical reactions inside the cells. In electrolytic cells, electricity is given to the cell to make a chemical reaction to occur. So in this unit, we will mainly concentrate on the first type of electrochemical reaction, where electrochemical reactions where electricity is produced due to chemical reaction. We will concentrate mainly on this electrochemical reaction. In oxidation, release of electron occurs. For example, a zinc atom releases 2 electrons and becomes zinc ions. So here, release of electrons occurs. So this reaction we can call it as an oxidation reaction. In reduction, acceptance of electrons occurs. For example, an ion, copper ion, it accepts 2 electrons and form copper atoms. So here, acceptance of electrons. Acceptance of electrons are known as reductions. So now we studied about the definition of oxidation and reduction. In a redox reaction, both oxidation and reduction occurs simultaneously. That means in redox reaction, both release and acceptance of electrons occur. Electrochemical reactions are redox reactions. Then how to check whether the given reaction is a redox reaction or not? If both oxidation and reduction occurs simultaneously, then the reaction is a redox reaction. If oxidation is involved, then at least one chemical species will release electrons and gets a higher oxidation state. So in oxidation state of the species will increase. If reduction is involved, then at least one chemical species will accept electrons and gets a lower oxidation state. So oxidation state of one species decreases in reduction. If we can write the oxidation states of the atom in a chemical equation, then we can find whether oxidation and reduction occurred simultaneously and check whether the reaction is a redox reaction or not. Reaction or not. For example, I'm giving you one equation. Consider this equation. Hydrogen reacts with oxygen, forms water. How to check whether this reaction is a redox reaction or not? Very simple. First we have to find the oxidation states of all the atoms present in this reaction. For example, hydrogen in its elemental form, so its oxidation state is 0. Oxygen, oxidation state is 0. In compound, water is a compound, and in compound oxygen, oxidation state is -2. Hydrogen oxidation state is +1. Now you see, for hydrogen, what happens? Oxidation state increased. Oxidation state increases. If oxidation state increases for a species, then we can call that species undergoes oxidation. Similarly, here you can see oxygen oxidation state is decreased. So oxidation state decreases. So here a reduction in oxidation state happens. So we call that reaction as reduction. So in this reaction, oxidation also happened, reduction also happened. So this is a redox reaction. Second example, we will check whether this reaction is a redox reaction or not. Here, it is a famous displacement reaction. Zinc reacts with the copper sulfate forms zinc sulfate and copper. How to check whether it is a redox reaction or not? Zinc in elemental form, oxidation state 0, copper +2, oxygen -2, sulfur +6. You have studied how to find oxidation state of compounds. -2, +2, +6 and 0. Here, oxidation state of zinc increases. So this reaction is oxidation. Copper in copper sulfate has an oxidation state of +2. Now it reduced it to 0. So a decrease in oxidation state happened. So this reaction is reduction. So in this reaction, both oxidation and reduction occurs. So we call this reaction as a redox reaction. How to check whether the given reaction is redox reaction or not? Another example, third example. Hydrochloric acid reacts with the sodium hydroxide and forms sodium chloride and water. A very famous neutralization reaction. We will check whether this reaction is a redox reaction or not. We can write the oxidation state of all the atoms in this reaction. Chlorine in compound form -1, hydrogen +1, hydrogen +1, sodium alkali metal +1, oxygen -2, sodium chloride -1, sodium +1, water, oxygen -2, hydrogen +1. We are going to check whether any oxidation or reduction happens. Is there any species which got a higher oxidation state in this reaction? Hydrogen +1, in right side also, hydrogen +1, there is no change in the oxidation state of hydrogen. Chlorine atom, Cl-, there is no change in the oxidation state of chlorine. Sodium, no change. Oxygen, no change. So there is no change in the oxidation state of atoms which took part in these chemical reactions. So this is not a redox reaction because here there is no oxidation, here there is no reduction. So this reaction is not a redox reaction. So in this neutralization reaction, no atoms changed its oxidation state when they took part in chemical reactions. So this neutralization reaction is not a redox reaction. How to find the oxidation state of atoms? You have studied this in your school, but if you forgot, then I will give you some hints to remember all the concepts that you studied in your school. All atoms in their elemental form has an oxidation state of 0. So if an atom stays alone, then its oxidation state will be 0. If you add the oxidation states of all the atoms in a compound, gives a sum of 0. Except in hydrides like sodium hydride and potassium hydride, hydrogen generally shows an oxidation state of +1 in its compound. Except in peroxides and superoxide, generally oxygen shows an oxidation state of -2 in its compounds. Alkali metals like lithium, sodium, potassium, rubidium, they show oxidation state of +1 in most of their compounds. Alkaline metals such as calcium, barium, they generally shows an oxidation state of +2 in their compounds. Halogens such as fluorine, chlorine, bromine, iodine, they generally shows an oxidation state of -1. Transition metals, they shows different oxidation state. Zinc, copper, in most of the compounds, their oxidation state is +2. Silver also, its oxidation state is, most of the compounds, it will be +1. For aluminium, it is +3. In majority of the compounds. There are exceptions also. Now we will study how to find the oxidation state of atoms in a compound. Two examples we will study. First one, potassium dichromate. We know that potassium is an alkali metal, so it has an oxidation state of +1. Oxygen is having an oxidation state of -2, but we do not know what is the oxidation state of chromium. As per the second rule that I discussed in the previous slide, if I add all the oxidation states of all the atoms, then the value should be 0. The sum should be 0. We will do that. 2 potassium atoms are there. Each potassium atom has an oxidation state of +1. So 2 into +1 plus 2 chromium atoms, and we do not know what is the oxidation state of chromium. So that is X plus 7 oxygen atom. Each oxygen atom has an oxidation state of -2. If we add all these things, we should get the value as 0, sum as 0. So 2 plus 2x minus 14 equal to 0. 2x minus 12 equal to 0. 2x equal to 12. X equal to 12 by 2 plus 6. So here oxidation state of chromium is +6. So we can write oxidation state of all the atoms in potassium dichromate K2 +1, Cr2 +6, O7 -2. If you want to check whether you have done it in the right way, you just add all the oxidation states of all the atoms, then you should get the value as 0. Second example, potassium permanganate, a famous oxidizing agent. How to find oxidation state of all the atoms? Potassium alkali metal +1, oxygen -2, manganese we don't know because it is a transition metal. Once we add all the oxidation states of all the atoms in this compound, we should get the value as 0. So potassium, 1 potassium atom, so 1 into +1. 1 manganese, we do not know what is the oxidation state of manganese, we consider it as X. 4 oxygen atom, 4 into -2, total 0. 1 plus X minus 8 equal to 0. X minus 7 equal to 0. X equal to +7. So now I can write all oxidation state of all the atoms. K +1, manganese +7, oxygen -2. We will study about what is an oxidizing agent and reducing agent. In a chemical reaction, especially in a redox reaction, the chemical species which helps other species to get oxidation is known as oxidizing agent. So oxidizing agent will help other species to get oxidation. Don't be confused. Oxidizing agent won't undergo oxidation. Oxidizing agent helps other species to get oxidation. Similarly, the chemical species which helps other species to get reduction is known as reducing agent. So a reducing agent which will help the other chemical species to undergo reduction. We will take an example. Very famous displacement reaction. We are writing oxidation states. Zinc undergoes oxidation. because it changed its oxidation state from 0 to +2. Copper in copper sulfate undergoes reduction because its oxidation state decreased from +2 to 0. So in this reaction, who undergoes oxidation? Zinc undergoes oxidation with the help of copper sulfate. So when zinc reacted with copper sulfate, zinc got oxidized. So who helped zinc to get oxidation? Copper sulfate. So copper sulfate is oxidizing agent. Similarly, who undergoes reduction? The copper sulfate to copper. That conversion is a reduction reaction. Copper sulfate undergoes reduction when it reacted with zinc. So zinc helped copper sulfate to undergo reduction. So zinc is reducing agent. In this reaction, copper reacted with the silver nitrate, formed copper nitrate and silver. This is also a displacement reaction. So here, what happens to the copper atom? Copper atom got an increase in oxidation state. That's why copper undergoes oxidation. In silver nitrate, the oxidation state of silver was +1 and it converted to 0. So there is a reduction in oxidation state of silver happened. So silver nitrate undergoes reduction. So here, who undergoes oxidation? Copper undergoes oxidation with the help of silver nitrate. So silver nitrate acts as oxidizing agent. Similarly, silver nitrate undergoes reduction with the help of copper. So copper here acts as the reducing agent. In a voltaic cell, electrochemical reaction occurs. And electrochemical reactions are redox reaction. So in a redox reaction, both oxidation and reduction occur. Now, in a voltaic cell, the electrode at which oxidation occurs is known as anode. In a voltaic cell, the electrode at which reduction occurs is called cathode. Now, how to check or find which electrode is anode and cathode? That we will study in the next class. Welcome to the third lecture, and the topic is origin of electrode potential. We have studied about components of galvanic cells. Mainly four components: anode and cathode. These are the electrodes. The electrode at which oxidation occurs is known as anode. The electrode at which reduction occurs is known as cathode. Electrolyte will act as a conducting medium. Salt bridge will help to maintain the electrical neutrality in the cell. Inside the galvanic cell, chemical reaction will occur, and due to the chemical reaction, electrical energy produces, and electrical energy production leads to electromotive force or cell potential, which can be calculated using the formula cell potential of the galvanic cell equal to cathode electrode potential minus anode electrode potential. This equation suggests that the cell potential is the difference in the electrode potentials of cathode and anode. This indicates that each electrode, cathode has its own electrode potential and anode has its own electrode potential, and their difference will give you the cell potential. So now we got an idea that individual electrodes have their own electrode potential. We have to answer two questions. First, does the potential exist in electrodes when they are part of the galvanic cell as well as when they are staying alone? We studied electrodes have their own potential Now first question, whether that potential belongs to them when they are part of the galvanic cell as well as when they are staying alone. In both these cases, whether the potential exists in a single electrode. First question. Second question, how the potential in the electrode originated. What is the reason behind the formation of electrode potential in a single electrode? To answer these questions, we have to take only one electrode. That means only one metal rod dipped in its own solution. For example, here you can see zinc rod is in its own solution zinc sulfate. So zinc sulfate contains zinc ion, which is an ion of the same metal, that is zinc. Here you can see a drawing of a single electrode. A single electrode means one metal rod dipped in its own solution. For example, here zinc rod is in zinc sulfate solution. Zinc rod, it is solid and it contains only zinc atoms. Zinc sulfate solution contains zinc ions and it is now in liquid form. So zinc ions are in solution, zinc atom is in the metal rod. In addition to zinc ions, sulfate ions are also present in the zinc sulfate solution, as well as the water molecules that you used to prepare zinc sulfate solution. Now, if you dip zinc rod in zinc sulfate solution, what are the possibilities? Whether any reaction will happen or not, that we are going to check. First, the zinc atoms in the zinc rod has a tendency, I will call it as tendency, to release two electrons and becomes zinc ion. Zinc atoms in the zinc rod has a tendency to release electrons to become zinc ions. If it becomes zinc ion, ions cannot stay in the metal rod. What they have to do? They have to come into the solution. So first tendency, zinc atoms in the zinc rod have a tendency to release electrons and become zinc ion and go into the solution. So this reaction, if you see, this is a release of electrons. Equation involves release of electrons. Release of electrons means oxidation reaction. Oxidation reaction. So the tendency to become oxidized, the tendency of oxidation we call a name, that is oxidation potential. So the single electrode, that is zinc dipped in zinc sulfate solution, in which the zinc atoms in the zinc rod have a tendency to release electrons and become zinc ion and go to the solution. This reaction is oxidation. This tendency is known as oxidation potential. Now next question, whether this reaction will happen or not. Potential and happening, both are different. Here potential is there, tendency is there, but can it donate electrons or can it release electrons and go into the solution? Answer, no. Even though there is a potential for zinc atoms to release electrons, that reaction will not happen. I will give you an analogy to explain this. For example, I want to donate 1,000 rupees. So I have a tendency to donate money. But if nobody is accepting money from me, then even though I have a tendency to donate money, I can't donate. So donating money is a process, is an event. Tendency of giving money, that is not an event, that is not a process. So even though I have a tendency to donate, I can't donate. Same thing here. Here, zinc has a tendency to release electrons and become zinc ions and going into the solution. That potential is there, but it cannot undergo this reaction. The reason, if zinc is releasing electrons, somebody should be there to take that electron. So nobody is there to take that electron. That's why zinc cannot undergo oxidation itself, even though it has a tendency. Like the analogy, I have a tendency to donate money, but nobody is accepting that money, so I cannot donate money. But tendency is there, and that tendency we call it as oxidation potential. Now another tendency is this: zinc ions in the solution, they have a tendency to accept electrons and becomes zinc atoms. So who is having this tendency? Zinc ions in the solution have a tendency to accept electrons and become zinc atoms. Zinc atoms cannot stay in the solution. What it has to do? It has to deposit on the zinc metal rod. Always like this. Atoms will go into the metal, ions will go into the solution. So the second tendency is for the zinc ion in the solution. It has a tendency to accept electrons and become zinc atom. If it becomes zinc atom, then it has to deposit on the zinc rod. See this equation. This equation involves acceptance of electrons. So this reaction is reduction. So that tendency of reduction, we call it as reduction potential. So how many potentials are there? Two types of potential, two types of tendency. One is oxidation potential, that is for the zinc atom in the zinc rod. Second tendency is for zinc ions to accept electron to undergo reduction, and we call that potential as reduction potential. Whether this reaction will happen or not, this reaction is also not going to happen in a single electron. The reason, in order to undergo this reaction, somebody should give 2 electrons to zinc ion. Here nobody is there to give electrons. So zinc ions cannot become zinc atoms. It's like I need 1,000 rupees. Imagine in another situation, I need 1,000 rupees. So I have a tendency to accept money. But if nobody is there to give me that money, even though I have a tendency to accept money, I cannot accept. Understand? So this potential is known as reduction potential. So how many potentials are there? 2 potential. One is oxidation potential, one is reduction potential. Whether any one of these reactions will happen at a faster rate? No. Right? If first one is to happen, then 2 electrons somebody should accept. If the second one is to occur, then 2 electrons somebody should donate. So both these won't happen. So we call this the zinc rod. If you dip it in zinc sulfate solution, there won't be any change. And if there is no change in a chemical reaction, we call it as it is at equilibrium. So here, no change in the concentration of zinc ion, No change in the number of atoms of zinc. Clear? Now onwards, instead of reduction potential, I will use the word electrode potential. I will use the word electrode potential. So actually electrode potential is reduction potential. So two tendencies: to get oxidized, we call it as oxidation potential. Second one, to get reduced, we call it as reduction potential. Another name for reduction potential is electrode. Now we will study how the electrode potential in a single electrode is originated. What is the reason behind the origin of electrode potential? For that, we are taking the same example, zinc rod in zinc sulfate solution. It's a single electrode. Zinc rod contains zinc atoms and zinc sulfate solution contains negatively charged sulfate ion. We call it as an anion because it carries negative charge. Zinc ions, we call them as cations because they carry positive charge and they are represented using this symbol. Water molecule, which is there in zinc sulfate solution because we prepared zinc sulfate solution by dissolving zinc sulfate in water. So three types of ions or molecules present in zinc sulfate solution: sulfate anion, zinc cation, and water molecules. As per Helmholtz, this famous scientist, all metals have a tendency to absorb negatively charged particles. The reason, in a metal, the surface will have a charge density creation which attracts negatively charged anions. That means the charge creation or the charge density, very small charge density creation is of positive charge in metals. So all metals have a tendency to absorb negatively charged anions. So zinc sulfate solution contains numerous number of sulfate anion. Among those sulfate anions, some of the sulfate anions will move towards the metal rod and get absorbed on the surface. So I am drawing the absorption of anions, that is sulfate ions, on the surface of the zinc rod. Be careful, these ions are not reacting with the zinc rod, just absorbed. Now you got a layer of negatively charged particles. You can see now a negatively charged particles of anions is created on the surface of zinc rod, and we call that layer as inner Helmholtz layer. And it is negatively charged. Now you got a layer of negatively charged particles. Obviously, that layer will have a tendency to absorb positively charged cations. So in the zinc sulfate solution, we can see we have positively charged zinc ions. So what will happen? Among the zinc ions present in this zinc sulfate solution, some of the zinc ions will get absorbed on the negatively charged inner Helmholtz layer because opposite charges they attract. So I am representing the zinc ions which absorbed on the surface of the negatively charged cations. When cations are getting adsorbed on the surface of anions, those cations will be solvated. That means water molecule will be there along with the positively charged cations, or we call those cations as solvated cations. The solvation term came because of the water molecule is the solvent. So we got now a layer of solvated positively charged cations. We got a layer which consists of positively charged solvated zinc ions, and we call that layer as outer Helmholtz layer, and this layer is positively charged. How many layers it got formed? 2 layers were formed. One is inner Helmholtz layer, which is a layer consists of negatively charged sulfate ion. Just near to that layer, a positively charged layer formed due to the solvated zinc ions. Now the remaining portions in the zinc sulfate solution, there zinc ions, the remaining zinc ions will be there, remaining sulfate ions will be there, but one difference, the concentration of the ions will be lesser compared to this area. So here also we will get zinc ions, sulfate ions, water molecules, but this area now it is rich in charged particles or ions. This area is comparatively less concentrated in terms of sulfate ions and zinc ions. We know that some of the zinc ions moved into this area, some of the sulfate ions moved into this area. So the number of zinc ions and sulfate ions reduced in this area. So we call this area as diffusion layer. We call this area as diffusion layer, which contains zinc ions, sulfate ions with lower concentration. Now, we can see that 2 layers are formed, and those layers are of different charge, and these layers are separated by a small distance. Now, as per the electrochemistry, if you have 2 different layers or areas which contains opposite charges, and if they are separated by a distance, then potential will develop. So this potential is due to 2 differently charged layers. So there is a double layer, and this double layer is due to their different charge. So we give a name for these layers as electrical double layer. So electrical double layer contains one inner Helmholtz layer and one outer Helmholtz layer. Both layers are having different charge or opposite charge, and they are separated by a distance, so potential will develop. This is the reason why a single electrode gets its own potential. You can also identify the potential in this area will be higher compared to the potential in diffusion layer, because diffusion layer contains less number of or less concentration of zinc ions and sulfate ions. Rather, in this area, this inner and outer Helmholtz layer, the charge of the concentration of the charges are high. So if I draw a graph, potential against distance from rod, potential will decrease. Why potential is decreasing? Because the concentrations are decreasing. Up from here to here, the decrease will be a linear decrease. From here to the inner edge of this container, zinc sulfate container, then the decrease will be exponential. That is the only difference in the decrease. Actually, it will decrease from the rod to the inner edge of the zinc sulfate solution. From here to here, the decrease will be linear. After that, decrease will be exponential decrease. Now we study why potential is formed on summary of this session. Now we have answered two questions which were asked at the start of this session. We answered this question: does the potential exist in electrodes when they are part of the galvanic cell as well as when they are staying alone? We answered the question for how the potential in the electrode originated. So both the questions which were asked at the start of this session is answered now.